Okay, today's 9.5 Math Induction, Day 2. So today we're just going to spend some time in class doing some of these induction problems, and they're definitely challenging. But by now I hope you got the start of the process. You start with checking that n equals 1 will work. Now remember, this is a list of a whole bunch of terms, and if you choose n equals 1, you're choosing to only have one term. So I'm putting in a 1 right here, and that means this left side will only have one term, and it will be 4 times 1 is 4 minus 3 is 1. And we could have known that by looking right at the very beginning there, which I drew over, but there's a 1 right there. Okay? So the left side's 1. And did the right side correctly add them all up? Well, put in a 1 right here, and we get 1, 2 times 1 minus 1. And that's 1 equals 1 times 2 minus 1, which is 1. And 1 equals 1. Cool. It worked. I proved it. Okay. What's the next step? Dice of Destiny, should I call it? It's row 4, person 2. And that today would be you. What do you do to the second step? N equals K. You picked an easy one. So the dice picked you, but so I just rewrite this thing with a K in it. N equals K, just like you said. So I go 1 plus 5 plus 9 plus ... plus 4K minus 3. Stop, because you need to leave yourself room. If you know where we're going, the next step is going to be to add another term, the K plus 1 term. So leave space right there so that you can add that in later, okay? You can always probably cut, I think the way your iPads work, you can slice the middle of a thing and then slide it over, but if you can't, anyway, leave some room. And now I have K times 2K minus 1. Okay, now what's the third and brutal step? Just tell me what it is. N equals K plus 1. Now I'm going to do that by throwing it in right here. Right here is where I'm going to put that term. But don't just put K plus 1 there. You got to think about what would the next term be. So I got to put in 4, and that's where the K plus 1 is going to be. There used to be a K there. Now there's a K plus 1 there. Always remember the parentheses around it. So this becomes, the next term would be 4 times K plus 1, where the K used to be, minus 3. And if I do it to the left side, I got to do it to the right side. All right. Now what is there to, quote, do? What there is to do is we now take this and say that has to be rearranged until it proves that we're going to get the same thing as if we had dropped in a K plus 1 here and here. So I like to write that as a goal statement. I'm going to do it in bright green. I'm going to write goal, and you should too. K plus 1 in parentheses. How many times have I told you that a variable is an empty parentheses? You got to have the parentheses there or it's going to mess things up. 2, and again a parentheses where the n is, minus 1, and the parentheses gets a K plus 1. There, I have just recreated this, except with K plus 1s where the n's used to be. And that's because it says right here, let n equal K plus 1. All right, now the goal is to get this algebra steps are taken, and then eventually you get it to this goal right here. Okay, actually this whole thing, I should pause for a second while I loop that. Okay, I got that grouped together, so now I can bring this down as I do more and more algebra to it. All right, so here's the only hint I want to give you so that you don't just have no clue what to do. Here's a thought. Do you get that we are trying to get something over here that is not in factored form. Do you agree that is not a big multiply problem? This one is a big multiply problem. You get how you got this part and that part? This one's factored. This one's not factored. But the trick is I can't see anything that factors out of this and this. It's not like there's a k plus 1 in both of them like last time. So you still have to figure out what this factors to. So maybe you should just multiply it all the way out and try to find what it factors to. And here's the hint. We know one of the factors from looking at this. It's telling us one of the factors. So once you got this, the right side, multiply it all out, that's a big hint on how to get it to look like the goal. All right, this is the part where for the rest of the hour, you are going to just be working on induction problems and on the take-home portion of the final. I'm about to hand that out to you. Let me explain on video here the rules for the take-home portion of the final. First of all, the final is still going to be given on the last day of class during finals week and everything, but the good part is you get to control 1/3 of that by being able to do it ahead of time. I'm going to give it to you as a take-home. It also serves as a review packet for the final. Now, it is not all inclusive. In other words, this isn't a list of everything you have to know for the final. Okay, this is a bunch of things you'd have to know for the final. And there is more. Now, I'll be talking over more things that you should be ready for on the final, and I'll do that over the next few days. But this take-home part is due Thursday of next week. That gives you basically this weekend, Friday night, Saturday night, Sunday, and then next week, Monday, Tuesday, Wednesday. But my point is, if you don't do any of this take-home this weekend, then that means you're cursing yourself to having to finish the whole take-home portion of the final on Monday, Tuesday, and Wednesday night. You are not going to like that if you are on Monday night and you haven't started yet. Okay, I strongly recommend doing a bunch of it this weekend. In fact, I strongly recommend doing a bunch of it in class right now because I'm going to have you working in groups in class. Now, obviously then, you're allowed to work with other people on it. Now, there's a big, in the past, this take-home final, in past years, actually last year was the first year it changed, but before that, you weren't allowed to work with anybody else. So it's obviously a benefit to be able to work with somebody. And the reason we changed it is that what we find in situations like that is a lot of kids give in to the temptation to get help from somebody else. And then the kids that were being honest were being penalized because they wouldn't ask for help because they knew we weren't supposed to. And other kids were cheating like madmen, going to Caribou and doing it. So we rather just let everybody work with somebody else, and that's okay. But here's the rules. You can't ask the teacher, I'm not willing to do these problems for you. Okay, if you just think about that, if I just assign 35 questions per kid and everybody wants me to help them with only the 5 that I don't understand, and there's 150 kids that all want 5 different problems explained, I can't do that. There's not enough of me. I can't do that. Okay, so but you can get help from other kids, and there's a distinction between, hey, let's say that Nick and I are friends. I say, hey, can I see your number 4? And he says, sure. That's cheating. In fact, if we see you give your packet to someone else, that's going to cause you and them both to lose 30% off of your score. So you were going to get 100%, now you get a 70. Okay? So don't let anybody or copy yourself somebody else's paper. Now, can you ask Nick for some help on problem number 4? Sure. He can explain to you. That's okay. What he cannot do is hand you his paper. He can even show you on his paper that stays on his desk and say, here, look at step number 1, you got to do this, and then you got to do that. He can explain it to you. You may not copy his paper. You get the difference. Some kids are just going to totally copy somebody's paper. And I know that can still happen, but we just can't allow that, because if you allow copying of other people's papers, it would technically be okay for one really smart kid to do the whole packet. Everybody else just copies them. You know what I'm saying? If we make that legal, that's just craziness. Okay, so can somebody explain a problem to you? Absolutely. So kids could get together at Caribou and work through problems. That's smart. That's good. I encourage it. And you can ask help of adults even. It just can't be your math teachers. In other words, I won't help other teachers' kids either, because that, otherwise what's the point of not asking the teachers? Okay, so, but you can ask parents for help if they're good at math. You can ask your friends for help. You can use calculators. And you can use the power of the internet, and this is the exception. Again, what if Nick decides to post his paper on the internet so everybody can copy it? You said you could use the internet. That would be cheating for both of you. Yes? They're a lot like the test questions, yes. But like I said, just because we never asked it on the review packet doesn't mean it can't be on the final. So don't think of this as the only thing I have to worry about is this packet. Because your answer final is really small. This isn't that long, okay? But the actual, final has more questions on it than this does. This is just like a good start. And I will be talking about, I'll be doing a review with you. I'll say, okay, take out your iPads. We're going to do some practice problems. And I will do some that are on here that everybody gets stuck on, like nobody knows how to do number 5 or whatever. I might do something like that for the group, not for individuals. And I'll also go over some questions that may not be on the packet, but might be on the final. So I'll do some review with you, but this is not all inclusive. Yes? It's a good question. No, your final is still going to take you the whole time. Usually you don't have any trouble with people finishing it, but it's not like it's a short final. Any other questions? And this is just another way to think of it. If this bothers you, that oh my gosh, this is a final, just think of it as a review packet that just counts like homework, like a lot of homework, okay? Because no matter what, it figures into your grade, right? So it's just like a review packet that's valuable, lots of points. Any other questions? Okay, so in class in a moment, I'm going to ask you to get up. You're going to take your iPads with you. You're going to come up to the front of the room in a moment, and don't get everything, just your iPads. And then you're going to get in little groups of 2 or maybe 3. 4 is the biggest. And then you're going to go back out. You do not own your chair now. It's not yours, because other people can sit there to sit in groups, okay? So get your iPads, walk up to the front. I will probably do one more question on this video if I have the time. Otherwise, this might be the end of the video. I'll pause right now to see. Okay, so here we go. Answer for number 1 worked out. If you've already got it and you don't want to watch, as long as you've got it, I'm good. All right, I'm multiplying it out. 2 times k, 2k squared. Negative 1k is minus k. Plus 4k plus 4 minus 3. All said and done, 2k squared plus 3k plus 1. Now, it's a big hint to know that it's supposed to have a k plus 1 in it. So I take out a k plus 1. And I know you don't even see the k plus 1, but if you know it factors, and you know one of them is k plus 1, then you're left with, well, this has got to be then 2k. It's funny looking 2, but it's a 2. And a plus 1. And now you might be thinking, but Mr. Server, I get that when you multiply this out, that it makes 2k plus 1. But who figured out how to actually do something to this to turn it into 2 times the quantity k plus 1 minus 1? We need this to look exactly like this. You can't just say, so that's that. You have to shove some steps in there. Yes, ma'am. All right, so hold on. I'm going to say k plus 1 here because that doesn't change. And you're saying to take 2k plus 1 and then add 1. Wait a minute. I got to erase this to get myself a room. 2k plus 1. And you're saying, how can I just add 1 to it? And then you go minus 1. Why is that good? Because that brings in the minus 1 that we needed. And what's 2k plus 2 when you factor it? Exactly. If you can't finish it from there, your problem. I'm not willing to finish it. You should be able to make that work. And the master stroke is, you can't do stuff to both sides, but you can add 1 and then immediately subtract 1. So if you need that -1, that's a way to get it. All right. Now, hope other kids in the room have figured out problem number 2. I'm not going to do the whole problem number 2 for you, but number 2 on today's homework is definitely doable. Number 3, I'll warn you, is pretty tough. But if you're one of those kids that has done it before, then you know it can be done. Heck, you're going to test 1 first, and you'll know it's true. It's a true statement, so it must be true. It's a tough one, though. All right. For the rest of the hour, I'm going to encourage you to work on problem 2 and then the packet, which is the take-home. That's all I got for you for today.